So the very first thing we started out talking about polynomials. So if I ask if this is a polynomial, what are the rules to be a polynomial?
When it's be continuous, can't have like any angles.
The graph is smooth and continuous, no corners. What about the equation? What has to be true about your exponents? What kind of numbers?
Radicals, real numbers.
Real, something like that. It has to be
Real
like a whole
rational.
number.
The exponents have to be whole numbers. So 0, 1, 2, 3, 4. So no negative exponents, no fraction exponents. Can you have a variable under a radical or in a denominator of a fraction in a polynomial? No. So looking at these, is the first one a polynomial? No. Why?
Fraction, exponent.
Good. Alright. B. Is that one a polynomial?
Well, look at positive, it's not a polynomial. Yes.
Yes, if we multiplied it out, it would be a polynomial. What would be the degree?
Like 4.
4. If you multiply it out, you have 2, 3, 4. What would be the end behavior?
No, down.
Right. Degree 4 means it looks like parabola, but there's a negative in front. So both ends are pointing down. All right, C, is that one a polynomial? Yes. What is the degree? I tried to trick you on that one. So we're used to it being the first term, but it's the highest exponent, so that's 5. End behavior.
Up, down.
We have to look at that term with the highest power. So we know odds look like a cube, but because it's a negative, it would flip, so up, down. All right, D, is this one a polynomial?
Yes.
Degree?
7.
In behavior.
Down.
And it's an odd degree, so it looks like a cube. All right. Any questions on this? Knowing if it's polynomial, finding a degree and in behavior. Are we good with all of that? Alright, so the next thing, we're going to look at the graph and use it to answer some questions. A, what is the minimum possible degree? I want everybody to take a second, don't say it out loud yet. See what you think and write it down on your paper. I want to look. Can you tell me, does this have an even or an odd degree? Even. How do you know that? The ends are going the same direction, so it's an even. How many turning points does it have?
3.
And remember, the degree is always at least one higher than the number of turning points. So if there's 3 turning points, it has to be at least degree 4.
I looked at the wrong question. Yeah.
We know it's an even. Now it could be higher, it could be a 6 or an 8, but the smallest possible would be degree 4. What is the domain of this graph? the range going from the bottom, so it's coming from negative infinity. The highest point we hit ranges the y value, so that would be point B. And it would get a bracket because we do hit that point. Okay, if I ask for extreme points, what am I asking for? So tell me all those points.
A, B, E, F.
And since it's local, that doesn't mean, it doesn't have to be the highest or lowest on the entire graph, just for surrounding points. So I think,
C, D.
okay. So is AB a local max or a local min? Max. EF is a min, and CD is a max. Okay, D, I want the absolute extreme. So local extreme just says higher or lower than the surrounding points. Absolute is the highest on the entire graph and the lowest on the entire graph. What is the highest point on this entire graph? So AB is both a local and an absolute max. Do we have a lowest point on the entire graph? This one, but I don't know if you can tell from my picture, but maybe if you had it pulled up on Classroom, it's a little bit easier to see. Those are arrows right there. Yeah, sorry, they kind of look like endpoints from this picture. But those are arrows. So if those keep going down, do we have a lowest? No. If those had been endpoints, then EF would have been my absolute min. Number 3. I want a polynomial with degree 8 and zeros, negative 3, multiplicity 4. So what would I have to write? If negative 3 is a 0, what goes in my polynomial? Multiplicity of 4, so 1, so we would have multiplicity of 3, and if 0 is a 0, what do we put? An x. So you could put it anywhere. I'm just going to throw it in front, but it doesn't matter if you put it at the end. Is that degree 8? Yeah, so that's all we need. So we have another writing a polynomial one. So if I look at this, we hit the x-axis at -2. So that means we need an x plus 2. What did you notice? What did the graph do at that point? It bounced. So what does that mean? Even powers. So let's just go with 2. Where's the next place we hit the x-axis? 3. So it would get an x minus 3. That one went through, so we know it has to be an odd power. So we could just leave it to the first. Okay, what else do we need to look at?
It's a negative.
How do you know that?
Because it's up, down.
The end behavior is flipped, so we know it's a negative in front. Could we find out what number had to be out here exactly? What's the y-intercept?
4.
4. So remember, to get the y-intercept, if you plug, we know there could be a number out front. If you plug in 0 for all of your x's, this has to equal 4. So this would be negative 12a equals 4. That multiplied by -12, and it's -1/3. So we got the negative just like we said we should. So this has coefficient of -1/3. And again, the only way I was able to get that coefficient is because I knew the y-intercept as my graph. I want you guys to try number 5. So if we're dividing by x plus 4, what number do we put outside? -4. So always the 0 with that. Then we do our coefficients. So we have a 1x to the 6th, and 0x to the 5th. -16x to the 4th, 0x cubed, 1x squared, 0x, and -16. Did you guys forget your zeros?
I forgot one
Did
0.
Forgot one of them. There's a lot to include there. Okay. So 1 comes down, multiply. I think you guys know how to do the synthetic ones, as long as you don't forget your zeros. So that's 16, 0. So remember the remainder constant x squared, x to the 3rd, x to the 4th, x to the 5th. Okay, so we have 0x cubed, 0x squared. So this is my quotient. Is it a factor?
It's
Yes. How do we know?
equal to the last number of 0.
Alright. If we had gotten a remainder of 10, for instance, how do you write that in your quotient?
You write it up here.
Plus, yeah, 10 over x plus 4.
Okay. So if you have a remainder, you just add that on over what you were originally dividing by. Any questions on that one? Next one. Polynomial of degree 8. So how many zeros should we have? 8. We have 3 multiplicity of 2. So how many zeros does that count as? 2. 6i, -4 minus I, and 3 plus 5i. So I only gave you 5. What would be the remaining zeros?
Negative 6i, negative plus I, and 3 minus 5i.
Wow.
How'd you get it?
Oh, it's just the opposite.
Right. I didn't even give you the polynomial to divide them, but we had a rule that said the imaginary zeros come in pairs. So if you have one imaginary zero, the conjugate also works. And that's only for the imaginary numbers, not the real numbers. So the 3, we don't also have a negative 3. So then we got into graphing polynomials, which is what we did last week. To graph them, I had a series of steps that I asked you to go through. So let's start with those. What is the degree of this polynomial? 5. 2, 3, 4, 5. What is the end behavior?
Up, down.
Odd degrees look like a chair, but the negative front flips it. Zeros and multiplicities. What makes x minus 1 equal 0? multiplicity.
Two.
What makes x minus 3 equal 0? 3 multiplicity 2. And the last one, make sure you include those multiplicities. Alright, now we have to decide if a graph will go through or bounce at each 0. So at 1, the multiplicity is 2. So you look at the multiplicity. Even multiplicity means bounce. 3, multiplicity is 2, so it will also bounce. -4 just had a multiplicity of 1, so that one. And then how do we find a y-intercept? Okay, so 0 minus 1 is -1 squared. 0 minus 3 is -3 squared. 0 plus 4 is 4.
Wait, positive one. Oh wait.
If this is a positive and then that's
Yeah.
negative.
That's it.
Okay, so on my graph, we know it should start up here and end down here. We hit the x-axis at 1, 3, and -4. And the y-axis is at -36. I'm gonna count by -4. So my graph starts up here. At -4, what does my graph do? Through at -4. Okay, at 36, that's where we cross the y-axis. We hit at 1, and our graph would bounce. We again at 3, and it bounces. So final graph looks something like this. Notice I didn't hit the x or y axis anywhere except the points I had marked. Any questions on that one? Right, so we're going to do another one, but it's going to pull in what we did yesterday as well. So how many zeros can this one have? What's the degree of this? Degree. Since it's all multiplied out, you just take the highest one. And the degree is the same thing as the maximum number of zeros. We know it has 3 zeros exactly, but it's possible some of them could be imaginary. So at most 3 of them are real. In behavior, okay, but this one isn't factored. It's not something I can factor easily. So we're going to have to list all of our possible zeros to do that. So our p-value. What are all the p's?
1, 2, 3, 4, 6.
And q. So possible zeros, p over q. All of them still get plus and minus, so 1 over 1, 1 over 2, 2 over 1, 2 over 2 is 1 and we've got it, 3 over 1, 3 over 2, 4 over 1, 4 over 2 is 2, and we've got it. 6 over 1. 6 over 2 is 3, and we've got it. 12 over 1. And 12 over 2 is 6, and we've got that one. Alright. Now, how do we find 1? We plug them into this polynomial, and what do we want it to equal?
0.
Alright, start checking. Let me know when you find
Synthetic division.
synthetic division. So we have a -4, and our coefficients were 2, 3, and 23, 12. Oh, wait, negative. So we get down to 2x squared minus 5x minus 3.
Oh, wait. I don't know -4, so it's like
Well, it did give us a 0 for our remainder, so it did work. So now what?
I'll need to try factoring that out.
So we can do 7 side. So we get x minus 3, 2x plus 1. What else would be in there?
X plus 4.
So what are the zeros?
-4, positive 3, -1 half.
Would the graph go through or bounce at those? All of them, because they all have a multiplicity of 1. Okay, y-intercept. So if you think back to the original, and you plugged in a 0 for all of your x's, what do we get? -12. Okay, so now we plot all this stuff on the graph. So y-axis is -12, x-axis at -4, positive 3, and -1 half. We know the end behavior was down up. So it should start down here. We said it went through all the zeros. So pick that one, go through. Come back and hit the next one. We have to go all the way down here to hit our y-axis. All the way up to hit there. So there's our graph. Any questions on that one? Okay, so one last question. We have a polynomial and 3i is a 0. We have to find all the remaining zeros. So what would I do first?
Do synthetic division with it.
Three comes down. 3 times 3i is 9i. If we add, we get negative 1 plus 9. Okay, if we multiply by 3i. Negative 3i. This would be plus 27i squared, which is minus 27. That's a negative 3i. Positive 3i times negative 3i is negative 9i squared, which is positive 9. Now this isn't pretty yet, but if 3i is a 0, what else do we know? So we'll divide again with negative 3i and the answer we just got out. Remember, we leave off the remainder there. So 3 comes down. 3 times negative 3i is negative 9i. Gives us negative 1. Negative 1 times negative 3i is positive 3i. And that gives us 0. So we have 3x minus 1. So what makes that 0?
1/3.
So I asked for the remaining zeros. 3i was given to us, so the others were negative 3i and positive